Hi, I'm Tafline Ramos. I am Global Practice Director for Quality Engineering and Quality Assurance at Planet, one of the world's largest pure play software testing and quality consultancies. My work with Planet is predominantly in the areas of lifecycle optimization, quality engineering, and testing. And I'm also co-editor of the ISO 29119 software testing standard and have recently contributed to the development of the IEEE 2675 DevOps standard. Now, before I get started with my presentation, you might be wondering about my accent and where I'm from. I am from Australia. I live in Melbourne, although I have an American husband, and he has taught me a lot about American culture and especially how to pronounce my R's correctly. So hopefully you'll be able to understand me well throughout the presentation. I'll do my best to speak as clearly as I can and avoid too many Australianisms. So I'm here today to talk to you about quality engineering and how you can utilize quality engineering practices from the past and the present to not only accelerate the delivery and improve the quality of your applications, but also to make testers more valuable to their organizations and their industry. And really, the presentation is about how to evolve the role of the tester into one of quality engineer so that we can enable testers to be part of building quality in throughout the life cycle. So, something that my presentation is actually also about is really overcoming the eternal challenge that many testers face in our profession. And that is, by definition, in at least most people's minds, testing comes after development. The problem is, you can't test quality into a system. You can only build the quality in, of course. And bugs found after development create rework for developers and often for requirement engineers or business analysts that are collecting those requirements. As a result, testing is often seen as something that slows the flow of delivery to production. So as testers, really we need to look at how can we transition our roles to help our teams build quality in. And I believe quality engineering is one such approach to assisting with that very, very challenge. And really what this is about is looking at how we can adjust people's mindsets to recognize the importance of including testers and people with a quality mindset much earlier in the life cycle. So the key takeaways for the presentation that I'm going to cover are how quality engineering can be used to improve product quality, reduce rework, and accelerate delivery to production, how transitioning from a role in testing across to quality engineering will not only help you improve the quality of the systems you test, but will also make you a much greater asset to your organization, your industry, and your profession. And we're going to have a look at what you can do to transform yourself from a role in testing to one of a quality engineer. First, I wanted to look at the evolution of where quality engineering came from, or at least modern quality engineering. Quality engineering really is derived from software engineering. In software engineering, we're aiming to build the right product by making sure we understand and capture our end user requirements accurately, by then designing and building a solution that meets those requirements, by using testing to provide feedback on the quality of the product to confirm whether or not it meets its requirements, and using tools, methods, metrics, and process improvement to improve the process, make it more efficient and more precise. Now, in quality engineering, our focus is on building quality in. So quality engineering practices are all around validating the requirements to make sure they are captured accurately and completely, but also identifying project and product risks or quality risks that could prevent us from meeting those requirements, and to also identify gaps or potential gaps in the requirements. We then validate the design and the architecture and the build and the configuration as well to make sure that what we're building all the way through meets the requirements. We're looking at using continuous quality across the full software engineering lifecycle, not just testing at the end, of course, but quality engineering practices that can be used to help build quality in. And we're looking at shifting quality to the left and to the right, of course, right out into production as well, to make sure our systems, when they're in production, are being monitored and managed appropriately and maintained well, of course. In quality engineering, we're also using tools, methods, and metrics, but we're also using automation, of course, to accelerate the process, and life cycle optimization or delivery optimization to really optimize the whole software engineering process so that it's geared towards building quality in and determining whether quality is present as early as possible. Now, if we have a look at a brief history of where these concepts emerged. Now, if I was to write a full history on quality engineering, software engineering, and testing, of course, any one of those topics would warrant an entire presentation on their own. So please forgive me if I've missed any of your favorite textbooks or pieces of work or key moments in the history of all of these topics. I've done my absolute best to capture the key, most important aspects at least. So the concepts of quality actually could arguably date back about 400 years, depending on what you're reading into. But modern quality, at least in the last 80 years or so, Dr. Feigenbaum was one of the first people to write on quality concepts, and he wrote a book called Quality Control and a book called Total Quality Control, which was subsequently republished a number of times between 1945 and 1961. What also happened in this period was the Plan, Do, Check, Act cycle was developed by Schuhart and Deming, and the American Software Quality Institute was formed. American Software Quality Society was formed. Now, shortly after that, in 1966, Anthony Otteniger referred to software engineering in a letter to the members of the ACM, for which he was president at the time. NATO in 1968 held a conference on software engineering, the first conference on software engineering, in fact. And in parallel to that, of course, the legendary Margaret Hamilton defined the terms software engineer and software engineering in her work with NASA on the Apollo program. Not long after that, 9 years later, of course, The Art of Software Testing was published by Glenford Myers, and another absolute legend of software and testing. And this book is still relevant today, and many of the techniques, in fact, all of the techniques that were described in that book, of course, are still used in testing today. Now, what happened after that is there was a number of different standards published, the IEEE 829 standard, the IEEE 10008 standard, and the British 7925 component testing standard. What we also saw in the lead up to the Y2K bug, which was a pivotal moment in the history of testing, we had the International Software Examination Board establish the Certified Tester Syllabus. And at this point, this was very close to when Y2K was ramping up. Essentially, what we saw in our industry is before the Y2K bug, people who were doing testing were typically software engineers. They were usually developers that were also doing testing. They might have been business analysts or requirement engineers that were also doing testing. Sometimes you had users doing testing, absolutely, but often people with quite a technical background were doing the testing. You didn't see that many people back then with a role whose job was solely to test. In the lead up to Y2K, really we needed so many testers to conquer the Y2K testing problem that a separate profession was established for testing. Now, while this separation of responsibilities and separation of duties provided an opportunity for people to really recognize the value and the importance of specializing in quality and testing as a career and the capabilities that brought and the acceleration that brought to the processes and practices of testing, really, that was a really valuable moment and a really fantastic opportunity for testers everywhere. And beyond that, ISTQB was established, and now ISTQB certified 700,000 people, over 700,000 people. In parallel to this, we did have some pivotal books on quality engineering and journals on quality engineering. And of course, throughout the 80s and 90s, there were some fantastic textbooks on software engineering as well. But what we really saw at the point of Y2K, just before and just after, was this separation of responsibilities. Now, the separation was a positive, but it also brought the challenge that in a lot of people's minds, that made testers responsible for quality and testing. Now, Agile came along in 2001, and that did assist quite a lot with building a whole team view of building systems and a whole team concept of sharing the responsibility for quality. However, even in Agile projects, in almost every Agile project I've seen, testers are still brought in too late. Even in Agile, they're brought in usually after the product backlog has been written and after the very first conversations have been held with the architects and the developers that are going to design the system. So by the time the testers come along, the requirements are quite fixed, and it's very difficult to have enough time as a tester coming into sprint zero with the rest of the team ready to build when you're saying, whoa, hang on a minute. I want to go and review these requirements for a few weeks and see if I can find some gaps. I want to run some risk workshops and see how the requirements might break. If by that time a decision has already been made on how to engineer that system, you're going to have the challenge as a tester that you're not going to be able to influence the mindset that is taken towards building that system early enough. So, pausing for a moment on one of the concepts we just talked about, which is quality in general. I really like Dr. Feigenbaum's definition of quality from his book, Total Quality Control, republished in 1983 at the time. Dr. Feigenbaum said, quality is a customer's determination, not an engineer's determination, nor a marketing determination, nor a general management determination. It is based on the customer's actual experience with the product or service, measured against their own requirements, whether those requirements are stated or unstated, conscious or merely sensed, technically operational or entirely subjective, and always representing a moving target in a competitive market. Now, you could add to that, quality is also not a government's determination, also ultimately not a tester's determination. It really comes down to how the customer perceives quality. Now, I also like Dr. Feigenbaum's definition because in his same book, he actually was one of the first people to say the words, quality is everyone's job. Of course, in order to build quality in and ensure quality is present, our best approach is to make sure we're implementing quality engineering practices that make quality everyone's responsibility. If testing and testers are seen as our main line of defense against defects, we are going to miss out on that opportunity to get them involved right up front, and it'll push quality far too far down the life cycle if we don't get them involved up front. So let's have a look at how testing compares to quality engineering. In testing, at least in the current world, we have standards like the ISO 29119 standard, which I did help write, and which is still a very important standard. And all of these practices are very important practices in software engineering. In testing, we talk about things like organizational test policies and organizational test strategies. We talk about test planning, test management, test design, test execution, all of our types of unit integration, system acceptance testing, functional and non-functional testing, manual and automated testing, and of course, test process improvement. Now, even if you added into that static and dynamic testing, static testing to most testers being inspections, walkthroughs, and reviews, those early lifecycle practices, it still has the word testing in it. And again, if we're associating all of these good quality practices with testers, but testers are brought in too late, it really misses out on that opportunity to build quality in and get the testers involved in building quality in. If we compare that to quality engineering, in quality engineering practices, where I believe the industry needs to move towards is creating organizational quality policies and organizational quality strategies and having organizational quality governance practices as a result. We need product quality management, product quality plans. We need continuous quality instead of continuous testing. We need to shift quality to the left and the right, not just shifting testing to the left and the right. We need to review artifacts across the entire software delivery lifecycle, including reviewing test cases. Of course, testers would never make errors in our documentation. No, not whatsoever. But by admitting that, we might have made some errors in our testing. We might have had some gaps in the test cases we designed. If we sit with developers and sit with architects and database administrators and requirement engineers for that matter, and people across the full life cycle as well as end users, and say to them, how complete are our test cases? That will assist us in not only filling gaps in the quality of our tests and delivering better quality to production, it'll also help to break down the barriers that are still there in a lot of organizations between development and testing. We can also talk, of course, about quality assistance, which is really working with requirement engineers and developers and early people further up the life cycle with understanding how they can review their artifacts and test their artifacts earlier and more effectively so that by the time that the system comes through to us for testing, hopefully there isn't much to test and hopefully there aren't too many defects as well. We can also talk about delivery optimization or lifecycle optimization rather than test process improvement. Really what we're looking at here is how do we implement quality practices across the full life cycle that do verify and validate the correctness of the artifacts and of the product as early as possible. So really what we're talking about is a shift in the terminology we use and the practices that sit behind that. It's not a dramatic shift, though. It's a subtle shift, but an important one. Now, for example, when a tester or a test manager writes a test plan or a test strategy for the system, often the test manager may look at the requirements. They may also run a quality risk assessment to determine whether there's any gaps in the requirements. And they'll talk to people across the team and they'll decide how the product needs to be tested. What we need to move forward to, I believe, is a situation where we work with the whole team on developing a quality plan and a quality strategy for the product we're producing. For example, we could run workshops not only to identify the risks in the system and how to test the system and to avoid those risks. We could be sitting with the whole team to say, how do you think we should approach the quality and the testing on this system? What kind of early life cycle practices should we be using? How can we team up and work together on those early life cycle practices? Can we sit with the architects and build architecture checklists? Can we sit with the developers and look at the kind of checklists they use when they're reviewing their code? And of course, sitting with everyone across the life cycle that's doing testing and peer reviewing each other's tests. Really what we're looking for is a whole team approach to quality and a whole team approach to testing. Really reframing the way people look at testing and quality so that they can see how testing and quality practices can be valuable across that full life cycle. So, what is a qualified quality engineer? If we were looking at transitioning from a role in testing across to quality engineering, what kind of capabilities and skill sets would we need? Well, a quality engineer, firstly, is cross-skilled. They need a range of functional, technical, and consulting capabilities across the life cycle because they need to utilize a range of quality engineering practices that help build quality in and validate and verify whether quality is present as early as possible. But they also need to be able to influence their team, influence management, and potentially influence executive management in understanding why, where, when, and how quality engineering practices can be adopted. They need to understand how to take a whole team approach to quality. As we talked about, instead of a test plan, we want a quality plan that everyone contributes to. And they need to be able to utilize a range of tools, techniques, metrics across the life cycle to support optimization of our life cycle towards an optimized quality engineering practice. Now, if we have a look in a little more detail about what that means, if we're transitioning from a role in testing across to a role in quality engineering, what are some of the skill sets that we need on a more detailed level? Testers traditionally, if we talk about functional testers who are more experienced at testing through the user interface, they would typically have quite a lot of skills in understanding requirement elicitation and manual testing. And along with that, they'd probably have quite a lot of skills in test management. These days, if you're an agile tester especially, you really need to understand how to plan and manage the testing and identify the risks and design the tests and execute the tests and do the reporting, a one-person shop, so to speak, in testing practices. So as a functional tester, you might not have as much experience with test automation, and you might have less experience with development. Now, if you've done a computer science degree or an engineering degree, or if you've worked as a developer, you might absolutely have some awareness of how to do test automation and development. And certainly in my past, I used to work as a developer in a past life before I moved to the dark side of testing. Now, if you're transitioning across to a role in quality engineering, you absolutely have to retain a lot of those skills. You still need to be able to understand how to review requirements. And in some ways, when you're writing test cases, you're really clarifying requirements. So the two go hand in hand. You need to retain those skills and the skills to be able to plan and manage testing. But what we're seeing is a real shift towards needing some more of the technical skill sets that test automators and developers have. So as a tester, if you're a functional tester, there are small steps you can take into moving into a more technical skill set and having a little bit of experience with automation, even if you don't know programming. If you have had programming as a past experience at university or in your career, then you could look at really upskilling in automation and, of course, becoming a quality engineer or a software development engineer in test is a way that some people refer to those people as. But you could become a test automator, essentially, who understands development, understands test design for the purposes of automation, while still retaining the ability to plan, manage, and design the tests. Now, what you can do if you're not as technical, there are still aspects of quality engineering capabilities that you can adopt, and it's sort of a stepping stone, a pathway that you can take over time. So one of the capabilities, of course, that you can develop moving to quality engineering is taking a whole team approach to designing the quality plan and the quality strategy and even the quality assurance and testing processes that are going to be used across that full life cycle. You can also work collaboratively on conducting quality risk assessments and raising team awareness of the issues surrounding quality risks and how quality risk assessments can help find gaps in requirements. Now, if you're willing to become a little more technical, you could, if you've never learned, you could learn SQL or SQL. There's plenty of tutorials out there that will assist you with learning SQL. Now, the benefit of that is actually that you can provide your developers with more evidence of the defects that you think might be present in the system when you are testing the system. You could also learn as a functional tester how to edit API scripts to cover, if we're running test automation at an API level, you could edit XML or YAML or JSON scripts to cover more scenarios. So even if you're not a test automator because you've never done development before, you could be editing the automation scripts, or at least the input files to the automation scripts, to cover a broader range of scenarios. That'll speed up testing, absolutely, and it will add value to the team and contribute to the increasing quality. And it will actually also allow you to become more technical. The more comfortable testers are with technical concepts, I find the more comfortable they are also with talking with developers and architects about potential gaps or areas of improvement that are possible within the design and the implementation of the system. And anything that breaks down those barriers between developers and testers is a positive. Now, if you have done development at university or in previous work to before you became a tester, of course, you could actually move into a role in test automation, but you could also collaborate with the developers by reviewing the unit tests that they're designing, or even any of the automated tests they're designing, whether they're using test-driven development, behavior-driven development, acceptance test-driven development. You could be peer reviewing the scripts for them to have a look at the scenarios they've covered and to see if there's any other scenarios they can cover in their automation. Now, if you're really technical and getting brave and getting comfortable talking with the developers about their code, you could even assist the developers with their code reviews. Now, I don't know a developer anywhere that wouldn't jump at the chance for someone outside of the developers to do peer reviews of their code. That frees them up for other work and provides greater confidence in the quality of their code. So if you're a technical tester and you're comfortable with coding, code reviews is something you can assist with. There are also a range of tools that you can use across the life cycle that will help accelerate the identification of issues and the improvement of quality early in the life cycle. One of the first things we can do is to build an integrated tool set. And I find testers are actually really good at building integrated tool sets with integration between Jira, test management tools like Qtest, X-Ray, TestRail, so that we've got traceability through the requirements, the design, the implementation, and of course, the testing and the defects. You can even extend that to integration, of course, with CI/CD suites and for continuous testing, continuous integration. And you can integrate even with release management tools so that you've got a fully integrated set across the life cycle. Now, as a tester, something that you can also do in your transition to quality engineering is you can pick up quite affordable, if not completely free tools off the internet to test your systems very early in the life cycle. There's plenty of tools that will test accessibility, performance, and security issues quite early in the life cycle. Now, they might not pick up every defect there is. Certainly, most accessibility tools, for example, only pick up about 30% of WCAG requirements. So it's not going to pick up all the defects, but any defect we find early on is one less defect we have to deal with late in the life cycle. So you might also not understand what the tool is telling you. You might find, for example, you find a security gap that has the billion lols gap, or at least the billion lols bug. Now, you might not know what the billion lols security vulnerability is, but if you take that to a developer, I guarantee they will understand what that means and they will be able to address it in their code. So you don't have to be an expert at the whole life cycle in order to shift quality to the left yourself. Now, there are a range of practices, other practices that you can use throughout the life cycle. I'm not going to go into these practices now in detail, and I will say that none of these practices are really new. Well, most of them aren't new. Really, what you need to do as a tester in looking at a role in quality engineering, and if you're looking to help your organization transition across to quality engineering, talk about these practices with your team. Ask them which practices they think would help uplift quality, and learn about these practices yourself to find out where you can get involved much earlier in the life cycle. Now, if anyone wants any more information on these particular practices or any other practices on quality engineering for that matter, I'm happy for you to reach out on email, send me a Zoom call, and I'm happy to catch up and discuss if people would like more information on that at a later date. More than happy to talk about it. So, what's the motivation behind this? In fact, the Chaos report has indicated that the number of projects that fail from year to year hasn't really changed in the last 15 to 20 years. Still, 19% of projects fail. 17%, according to McKinsey, go so badly that they threaten the company's very existence. 33% of companies that experience project failure cite inaccurate requirement gathering as a primary cause of the project's failure. And one study found that 41% of IT development budget was being consumed by poor quality requirements in a number of companies. So what can we do to combat this? Of course, quality engineering practices are all about helping projects succeed and delivering quality to customers sooner. Capers-Jones developed a lot of statistics and did a lot of research on this and compiled a large number of practices in one of his textbooks, software engineering best practices, actually. He identified a bunch of activities that you could implement across the life cycle that would remove defects from the system prior to production, and he ranked them in terms of their defect removal efficiency. He found that automated static analysis, requirement inspections, design inspections, architecture inspections, and pair programming are all significantly more effective at removing defects compared to system testing and even automated unit testing. Now, that's not to say that testing is not important. That's not to say that testing is not needed. What we need is a range of practices across the life cycle that can be used to determine whether quality is present as early as possible so that we can accelerate delivery. And really what we're looking to do is reduce the overall cost of quality and increase our speed of delivery to production. And the usual cost of repair curve, really what we're looking for is an ideal cost of quality that's much lower and drops right off when it comes to production release. So key takeaways. Really what I'm saying is testing in most people's minds comes late in the life cycle. The later a tester is involved in the production of a system, the less chance they have at helping build quality in. Quality engineering practices provide a much wider range of practices that can be used to build quality in and verify and validate whether quality is present much earlier in the life cycle than testing on its own can, therefore reducing the overall cost of quality and accelerating the delivery to production. And when you're looking at transitioning from testing to quality engineering, each skill that you gain gives you not only a greater ability to test the systems that you're testing and release better quality systems as a result, it makes you a much greater asset to your organization, your industry, and your profession, and of course, yourself. Thank you so much for joining my presentation. I hope you enjoyed it, and I hope very much to be able to come to a future software quality conference in person one day. Very much looking forward to your questions. Thank you so much.